Okay, when you set y is equal to 0, this implies my 4 over x minus 2 cubed is equal to 0. Is it ever possible for that fraction equal to 0? No. And my question is, why not? Because only way a fraction can be 0 is this turns into 0. There's no way that will ever turn into 0 because it's always 4. So the answer is none. Okay, y-intercept. Y-intercept means I'm going to let my x equal to 0. So that means I'm going to have that same thing as doing that, f of 0. 4 over 0 minus 2 cubed, which is going to give you 4 on the top and negative 8 on the bottom. And the answer is negative 1 over 2. That's the x-intercept. Domain. Okay. Now, Caroline, when we're talking about domain, what are we really talking about? What x can't equal. Okay? So, what is the number that x cannot equal there? 2. I know you were kidding. 2. Because if you put 2 there, the bottom turns into 0. So therefore, my domain is, okay, you can write it any way you want. You can write domain is equal to all, this is probably the easiest way, all reals, and x cannot equal to 2. Right. Let's go to 3. 3. My f of x is equal to 1 plus, no, I don't want you to graph it yet. We're all good, no graphing. If you did, that's great. If you didn't, it's alright. Alright. So, f of x is equal to this. So let's find the x-intercept. X-intercept, now we're big boys and girls, we're going to let y is equal to 0. If y is equal to 0, when you have a fraction, only way it could be 0 is if what? Top is 0. So 1 plus 5x is equal to 0 will give us x is equal to negative 1 over 5, and that's done. Yes, ma'am. Oh, yeah. Did it say asymptote? Yep. Okay. Just vertical asymptote. This one does have a vertical asymptote. The first one does. And that's where x cannot equal to 2. So that means vertical asymptote is when x is equal to 2. Alright. X-intercept, or y-intercept. Y-intercept means I'm going to let my x is equal to 0. So we're big boys and girls, so we can do that in our head. What does that turn into? What does y turn into? 1. Okay, domain. Okay, does this have a restriction? Yeah. X can't equal to what number? Negative 1/2. So domain is all reals. X cannot equal to negative 1/2. Okay, vertical asymptote. Kind of get the idea where the vertical asymptote is, right? Where's the vertical asymptote? When x is equal to negative 1/2. That's why it can't be part of the domain. Yes, Jasmine. How did I find vertical asymptote? You find it by taking a limit, checking the end behavior as limit as x goes to positive infinity, negative infinity. If you can do that, you're ahead of the game. But we'll get that next week. Alright. 4. F of x is equal to x to the third over x squared minus 1. It will always help you to factor everything out. This is x minus 1, x plus 1. Alright. X-intercept. We turn y into 0. We let y into 0. The only way that could happen is when what's 0? X to the third is 0. When is that true? X is equal to 0. Okay, y-intercept. Y-intercept means we're going to let what equal to 0 now? X into 0. Okay, we can do that in our head. The top turns into 0, the bottom turns into negative 1, so what's my y-intercept? 0. Okay. Caroline. Domain. All reals. And x can't be what? Just kidding. I know. Why do you think I called on you? Under pressure? Well, maybe you shouldn't take the final exam tomorrow. That's pressure. Come on, Caroline. I know. I know you're not. What numbers x cannot be? Come on, you're getting warmer. Okay. Yes. No, you do not have to graph it. Okay, the next one is vertical asymptotes. Hey, Caroline, I'm back to you. What do you think my vertical asymptotes are? Huh? X is equal to 1. Is there another one? You're killing me, Caroline. Killing me. 5. F of x equal to x to the third minus 2x squared minus 8x. All that over x squared minus 16. Alright, what I want to do now is to factor everything. I'm hearing voices. It's either I need to take some medication or somebody's talking here. Thank you. Okay, when I factor out the top, I'm going to get, I can take out an x, I'm going to get x squared minus 2x minus 8. And then in the bottom, that's difference of two squares, that's x plus 4 times x minus 4. Alright, can I factor the top some more? Yeah, what are my factors? X minus 4 and x plus 2. And then I have x minus 4 and x plus 2. You better pay attention. Okay. We factor because we see those reduce. Those are known as removable discontinuities. Okay? It doesn't produce a vertical asymptote there. It produces a hole in the graph. But you still, x cannot still be 4. It cannot be 4. Even though it creates a hole. So, make sure you keep that in mind. Now, what I have left is x times x plus 2, all that over x plus 4. Now, I do have a vertical asymptote, still, and that's at negative 4. So I have two discontinuities. One is at 4. Okay, so let's go ahead and state the domain first. My domain is all reals, okay, and x cannot equal to plus or minus 4. Because at negative 4 it creates a vertical asymptote, at positive 4 it creates a hole in the graph. Okay, so since we already know what a vertical asymptote is, my vertical asymptote is at x is equal to negative 4. Vertical asymptotes are called non-removable discontinuities. Devin. That's a removable discontinuity. If you were to graph it, there will be a whole open circle there at that point. If you could, yeah. You could, we couldn't, we didn't. If they reduce off. Alright. The x-intercept. I'm going to turn y into a 0. I'm going to let y into 0. That means I got to set the top into 0. X is equal to 0. X plus 2 is equal to 0. That's 1. And this gives me x is equal to negative 2. Okay, those are my x-intercepts. My y-intercept. Okay, my y-intercept is I'm going to turn my x into 0. So let my x into 0. And when I turn x into 0, I put 0 there, so top turns into 0. As soon as top turns into 0, as long as the bottom doesn't turn to 0, it's 0. So y is equal to 0. Alright? Alright, let's take a look at 6. F of x is equal to x to the second plus 4x plus 4, all that over x squared minus 4. What do you think I'm going to do before I do anything? Factor and reduce if I can. There you go. Are there factors of 4 that I can make 4 out of? 2 and 2? Okay. X plus 2. X plus 2. The bottom's difference 2 squares. X plus 2. X minus 2. They cancel out. I get x plus 2 on the top. I get x minus 2 on the bottom. So let's go ahead and take care of the domain and discontinuities and all that. Domain is all reals, but x cannot equal to what, Caroline? Oh my God, you're focused. Plus or minus 2. Where's my vertical asymptote, Caroline? What did I say when you... Thank you. What, somebody told you to stop telling her the answers. Because I want her to focus. Alright. My x-intercept. X-intercept is when y is equal to 0. So when I let my y is equal to 0, Caroline, what am I going to... See, you're already turning and talking. Okay? Just watch me. Okay. If I let my y is equal to 0, which one of these do I set equal to 0? Top or the bottom? Huh? You were going to get it right sooner or later. It was 50-50. Okay. That's my x-intercept. Y-intercept. Y-intercept is when I let my x equal to 0. So, put in 0 for x. What does my y turn into? What does that turn into when I put 0 in there? Negative 1. Why you guys answer with the question mark at the end? Negative 1? Alright. That was painful. Section 12. Okay, I'm going to throw out 3 and 4. Okay. Yes. 2. F of x is equal to 10 x to the third plus 20. There you go. It finally sun can't on you, and I'm going to keep calling on you if you're over there, way back there, not focused. All right. Find all the real solutions, all the real zeros. That means they want you to set this equal to 0. Okay, now, if I want to solve for that, I'm in trouble. I like to cut it in half, factor out what's common, but if there's nothing common I can factor out, that I can get x minus 6 or x plus 6 there. So I'm in trouble. So when I'm in trouble, I have to go to my p and q's. My p's, for the last time, are factors of the leading coefficient, which would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. My q's are factors of the leading coefficient, which would be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. My p over q's, I got to take the 1, put it underneath all of these, which would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Then I got to take 2 and put it underneath all of these, which is going to give me plus or minus 1/2. And then 2 over 2 is 1, so, and then 3 over 2 is going to be plus or minus 3 over 2. And then 6 over 2 is going to give me 3. I already have that. Then I'm going to take 5, put it underneath that. So plus or minus 1/5, and then plus or minus 2/5, and plus or minus 3/5, and then plus or minus 6/5. Then I got to take 10, put it underneath each one of those. Plus or minus 1/10, plus or minus 2 over 10, which is 1/5. I have that. Plus or minus 3/10, and then plus or minus 6/10, which is 3/2, right? Which I have that. All right. I have choices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2, 24 different options, possibilities. We've got to make our guess really, really good one here. Okay, and we're going to use synthetic division. 1, all right. I am hoping you are right. 21 minus 1 minus 6. Okay, who said 1 back there? Urban? Okay, Urban, you're either going to get credit or blame on this one. If you said 1, I know you didn't. Okay, that means you got to get 0 down there. Okay, let's see if Urban is right. Okay, 10 multiply, 10 multiply, 31. I'm getting really big all of a sudden. I'm not going anywhere close to that. Thanks a lot, Irvin. Leading us in a wild goose chase. So I might want to get a little bigger. So what should we go? -2? Alright, let's try that. -2. Jasmine said -2, right? Who was it? Okay. We blame it on Jasmine. Okay, 10 multiply. Okay, -20. Oh, that's not bad. I get 1. Alright, and then multiply -2. Multiply, get -3. 6. Jasmine, you're right. Alright. So, what we found was x is equal to -2 was a 0. What we have left, Emma, you're in or out? Come on. Don't be disrupting. Huh? She's taking a quiz. Thank you. No. No. She's taking a quiz. You gotta go and I gotta go. I gotta do this. Unless you come and explain to me why. No. We're not doing that. Go. You know where she lives. Ask her it there. No. You say you have to go. What are you doing here? Go. No. I don't want to see it. Alright, here we go. Let's factor. We're looking for factors of 10. Let's go 5x and 2x. I'm ignoring you. Get out of here. Okay, let's put 3 here, and let's put 1 there. And let's make that into a minus, plus, and that will work. So my other two zeros are, okay, a positive 3 over 5, and x is equal to negative 1 over 2, and there we go. Done. All right. Let's go to section 11. Yes, sir. 4. Yes, ma'am. 4, 2. 12. Okay, here we go. 2. Alright, I have y is equal to 2 cosine of 2x. Okay, frequency is 2, so that means my period is going to change. My period is 2 pi divided by 2, which is pi. How hard is this? Graph the cosine. Here we go. Y x. That's now, instead of being 1 and negative 1, that's going to be what? 2 and negative 2. That's going to be 0. And what is that going to be? 0 to where? Pi. Cut everything in half. Pi over 2. Cut that in half. Pi over 4. Cut that in half. Okay, that'll be 3 pi over 4. Done. Yes, ma'am. Okay, 4. But you need to sit down and shut up right now. Otherwise, you're going to get in really, really big trouble. Okay, number 4. Y is equal to negative sine of 2 pi x over 3. So I'm just going to rewrite this like this. Negative sine of 2 pi over 3x. So that's my frequency right there. So I'm going to take 2 pi. I'm going to divide by 2 pi over 3. That means 2 pi multiplied by 3 over 2 pi. 2 pi's cancel, and I get 3. So my period is 3. Okay. No, just say no. Let's get it over with. Alright, goodbye. You asked her. Get lost. There you go. Alright. A. Control the hormones and let it go right now. Okay? I don't want to deal with that anymore. Rest of the period. Here we go. Now, my period is 3. My amplitude is still 1, so 1 and negative 1. Y-axis, x-axis, okay? So, what I'm going to do is, I'm going to put 0 here and 3 there. What's halfway between that? 3 over 2. What's halfway between that? 3 over 4. Well, what's halfway between that? That's going to be adding 3/4 plus 3/2, which is going to give you 6 plus 3, 9/4. I'm just cutting everything in halves. Those are my x values. Now, this is a negative sign. Sign starts right there at the origin. Okay, it goes up, but this time it's going to go down, and then it's going to go back to the middle. It's going to go to the top, come back down here. So there it is. Done. Alright. 11. Number 11, I have y is equal to 1 plus cosine of x minus pi over 2. Okay, this is a cosine function that has an amplitude of 1, because there's 1 right here. But that's really the vertical shift right there. They just put it out in the front. Okay, so you have a vertical shift of 1 unit up. And this is my horizontal shift, or known as, sometimes called a phase shift. Okay, that is pi over 2 units to the right. Okay, and the frequency is 1 because it's 1 right there. So that means my period is 2 pi. Period is 2 pi. So what is the hardest thing to take care of is this. So I'm going to take care of that at the end. Okay, so it's up to you. You can do it any other way if you want to. I know some teachers do it differently than I do. Just for me, it's just easier to do it this way. Just make sure you got the right answer. Okay. Okay, here it is. I have a vertical shift of 1, so I'm going to go up here, call that 1, and draw a new horizontal. The reason I drew a dotted line for y-axis is because I'm going to erase that pretty soon. Okay, once you have this, okay, you're going to go to 0 to 2 pi, so we're going to call that 0, call that 2 pi, we'll call that middle, that's pi, and the middle, that's going to be pi over 2, and the middle, that's going to be 3 pi over 2. I'm cutting everything in halves. Okay, and then my amplitude is just 1, so I'm going to go up 1, that puts me at 2, and go down 1, that puts me at 0. So that's my high value, and this is my low value. Okay, this is a cosine function, positive cosine function. So I'm going to start here, and then I'm going to cross the middle right there. I'm going to hit the bottom right there, and then go back to the middle at 3 pi over 2, and then get back to where I started at 2 pi because my period is 2 pi. I'm going to go ahead and sketch the graph of this as this. And like I told you, I have not taken care of the horizontal shift. Now this is an option you have. Some teachers actually take care of it up front, okay? Then you have to change everything around, or I can take care of it at the end. Now this means I got to move everything pi half units to the right. That means I have to either move every single one of my points, okay, pi half units to the right, or I can move my y-axis pi half units to the left, one or the other. So I'm just going to move my axis pi half units to the left. That way I'm going to have to add pi halves to everything. So what do I get when I add pi halves to 0? What does the 0 turn into? Pi halves. Okay? And what does pi turn into if I add pi halves to that? Pi. So what does pi turn into, what does pi halves turn into? Okay? What does pi turn into when I add pi halves to that? That will turn into, now, 3 pi over 2. What does 3 pi over 2 turn into if I add another half a pi to that? 2 pi. Okay? So let's make that 2 pi. And then what does 2 pi turn into if I add another half a pi to that? What's that? Say that again. 5 pi over 2. Okay, now notice my y-axis is all messed up right now because y-axis has to go through 0. You're interrupting the instructional time of my student right now, Jake. And you're going to get wrath of Mr. Sabaya soon. Alright, I have to move my axis to the left. That turns into 0. That is 2. Okay, this is 1. Okay, so I'm just transferring everything that I have on my y-axis over to the left. Now it will match up. So So I'm just going to erase my old y-axis. Okay, and this is the graph of that function. Alright, whatever is easy for you, make sure it's right. Okay, that brings us to problem number 12. Problem number 12. This one has everything in it. Y is equal to 2 minus 3 sine of 2x minus pi over 2. Now, if you can do this problem, you can graph anything. First of all, you need to rewrite this in a nice, easy form to read, and I will do that for you. This is negative 3 sine. I need to factor out a 2 from there. But if I do that, I have to factor 2 out of there too. So that means when I pull out a 2, I get an x. When I pull out a 2 out of this, I'm going to get pi over 4. Think about that. Basic algebra. Okay, when I multiply it together, I get the same thing. And then at the end, I have a plus 2. This is my amplitude. My amplitude is 3. This is my frequency. Okay, frequency is 2. But frequency also tells me what the period is. So my period is 2 pi divided by 2, which is pi. This is my horizontal shift. Okay, that is pi over 4 units to the right. And this is my vertical shift, and that is 2 up. Yeah. This 2 right here? Is there? I just moved that to the back. Because it's a plus or minus. Just plus. Alright. So, what I'm going to do is, I'm going to take care of this at the end. Because it's easy for me to do that. You don't have to, but I choose to do it that way. Here's my x-axis. That means if I have to shift horizontally, I'm going to draw a temporary y-axis. But if you notice, it has a vertical shift 2 units up. So I need a new horizontal axis at 2. So that's my new middle. Right there. Okay, that's my y-axis, my x-axis. Alright, my amplitude is 3. That means I'm going to go 3 units up. That will put me at 5. I'm going to go 3 units down. That will put me at negative 1. So 5 and negative 1 from the middle. Okay, my period is pi. I'm going to call that 0. I'm going to go over here, call that pi. Then we'll start cutting everything in halves. So it's going to be pi over 2. It's going to be pi over 4. And it's going to be 3 pi over 4. Okay, now let's go ahead and plot the points. Okay, this is a negative sign. I start in the middle, but instead of going up, I'm going to go down. Okay, so I'm going to hit the bottom right there. Start there, hit the bottom there, come back to the middle there at the next point, and the next point I'm going to hit the high point right there, and I'm going to come back to pi. Okay, I am now going to connect the dots, and everything is taken care of except my horizontal shift. Horizontal shift is pi force units to the right. That means I have to add pi force to everything. Okay, now I'll show you what's easy. If I added 0 to pi force, what does that turn into? Pi force, right? Okay, that's going to be pi force. Oops, come on. So this is going to be pi over 4. Okay, now what is pi force plus pi force? Pi over 2. It's going to be pi over 2. Okay, and what do I get when I add pi force to pi halves? 3 pi over 4. Okay, so 3 pi over 4. What do I get when I add pi force to 3 pi over 4? Just a pi. Okay, what do I get when I add pi force to a pi? Okay, remember my y-axis has to be at 0. So which way should I move my y-axis? To the left or to the right? To the right? To the left. It's got to be at 0, right? So I got to move it somewhere to the left. Call that my new 0. Okay. So this is going to be my 2. Okay, this is going to be my -1. And that's going to be my 5. And I need to make sure go back and erase my old y-axis so it won't be confusing. Okay, that way I don't have to move all my points. Okay, so that is done. There it is. Alright, you guys are lucky that section 10. Next one is 3. Tangent squared, x minus tangent of x is equal to 0. So first thing I'm going to do, what's that? Factor out a tangent. What's left? Tan x minus 1 is equal to 0. I get tan x is equal to 0. I get tan x minus 1 is equal to 0. I get tan x is equal to 1. Where is tangent of x equal to 0? Wherever sine is 0 is where tangent x equals 0. Where is sine 0? X is equal to 0 and pi. And 2 pi, but we can't include 2 pi. Where is tangent equal to 1? Well, tangent equal to 1 where both sine and cosine are the same. It's here and it's there. And that means x is equal to pi over 4 and 5 pi over 4. Okay. Number 5. Alright, cosine of x plus sine of x is equal to 1. This is actually a pretty clever way to solve this. And my 8th grader last summer figured this out. What do you think I'm going to have to do? There you go. Square both sides. Okay, why? Because it works. That's why. Okay, watch. When I square this, I'm going to get cosine squared x plus 2 sine x cosine x plus sine squared x is equal to 1. I'm expanding a binomial. Well, cosine squared plus sine squared come together, they turn into 1. So it'll be 1 plus 2 sine x times cosine x is equal to 1. That's a trig identity. Now the 1's cancel out. I get 2 sine x times cosine x is equal to 0. Divide by 2, I get sine x times cosine x is equal to 0. Then set each factor equal to 0. Sine x equals 0. Cosine x equals 0. Well, where is sine x equal to 0? At 0 and pi. Where is cosine x equal to 0? When x is equal to pi over 2 and 3 pi over 2. Alright, I am assuming you guys are okay with the unit circle. Yes, sir. Number 4. Number 4. 2 cosine squared x minus cosine x is equal to 1. Okay. It's a quadratic. That means what I have to do. bring everything to one side. Okay, minus cosine x. Okay, minus 1 is equal to 0. And then we're going to factor. Okay, it's 2 cosine x. Okay, and then cosine x. Okay, I need a negative 1 right there and a plus 1 right there. So I'm going to get cosine x is equal to negative 1 over 2. And I get cosine x is equal to 1. Where is cosine x equal to negative 1 half? Well, it's got to be in the second quadrant and third quadrant. So negative 1 half, that means x is equal to 2 pi over 3. And then x is equal to 4 pi over 3. Where is cosine x is equal to 1? Okay, when x is equal to 0. Right. Section 9. Yes, Macy. 7. 8. 1. Who said 1? Tell him I'm not even going to do 1 in section 9. If you can't find sine, cosine, and tangent of 60 degrees, that means you don't know the unit circle. Yes. Alright, 7 and 8. Okay, 7. We're finding sine of 11 pi over 5. Okay, and then cosine of 11 pi over 5 and a tangent of 11 pi over 5. Okay, is 11 pi over 5 part of the unit circle? Okay, just punch in your calculator. That's what you have calculators for. Very good. I won't let you use a calculator on this final. No, because I'm not putting sequence and series there, so there's nothing in here that you need a calculator for. Yeah. Don't bring one. You don't need it. I need to know if you know your unit circle. I need to know if you know your trig. Alright, here we go. 8. 8 is 405 degrees. Okay, first of all, if you subtract 360, how much do I have left over? That means it will go around the circle once and then it will land right there. Can you find sine, cosine, and tangent of 45 degrees? Yep. Okay, we'll move on then. Alright, how about section 8? Section 8. Going, gone. How about section 7? Yes, sir. 1. What is it? 3. Okay, you're asking, is it even, odd, or neither? Okay, here we go. Let me, for the last time, let me review what even, odd, or neither mean, okay? Even functions are symmetrical to the y-axis. That's an even function. Odd functions are symmetrical to the origin. Okay, there's another section where it talks about symmetry. So to find out, all we're going to do is we're going to let our x is equal to negative x. And if we let our x is equal to negative x and simplify, if we get the same thing, then it is even. It is symmetrical to the y-axis. If we get exact opposite, then it's odd, since it's symmetrical to the origin. So let's figure that out. So 3, it says f of x is equal to x times 4 minus x squared. So let's put it in. Let's find f of negative x. I'm going to get a negative x, all that times 4 minus negative x to the second. Let's clean this up. I get a negative x times 4 minus x squared. Is this exactly same as that right there? No. So it's not even. So it's not symmetric to the y-axis. Is it exactly opposite of what it originally was? Yes. So it's symmetric to the origin. Okay? It's an odd function. Okay? Odd function, so it's symmetric to the origin, and even functions are symmetric to the y-axis. Got that, Jackie? How you doing there, Caroline? Good. Alright, let's go to section 6. Yes, Eleanor. 2. Okay, section 6, 2. Here we go. Number 2. F of x is x to the third. My g of x is third root of x. Alright, before we go any further, okay, because we're going to have to state the domain of composite functions, before you go any further, make sure you define the domain of each one of these. This is all reals. There's no number I cannot use there. Is there any number I cannot use there in that function for the x? No, because I can take odd roots of a negative number. So this is also all reals. I do not get any restrictions from the original function. So if I do, I got to keep that in mind. Now I'm going to find f of g of x. That means take g, put it in there. When I do that, I'm going to get third root of x to the third power, which is x. Now, does this have any restriction? Any number I cannot use? So the domain is all reals. Go the other way. G of f of x. That means take this one and put it in there, which looks like third root of x to the third, which is x. Is there any number I cannot use here? No. So the domain is all reals. That was the hardest question you had in that section? Good idea. Section 6, number 3. F of x is equal to x plus 1. G of x is equal to 1 over x. Okay, again, let me repeat this. You have to first identify the domain of each one of these functions. This is all reals. There's not a number I cannot use there. But I do have a restriction here. X cannot equal to what number? 0. I got to keep that in mind. I will tell you where you have to keep that in mind. If I find f of g of x, okay, this restriction of the inside function has to go with it. Okay, the inside function restriction has to go with the composite function. Okay, if it didn't exist in the g of x here, it won't exist in the composite function either. It's like your parents. If your parents didn't have genes for blonde hair and blue eyes, and you come out with blonde hair, blue eyes, you're in trouble. Okay? You didn't have a gene for that. Okay? Alright. So, when I take this, put that there, I'm going to get 1 over x plus 1. Then I might get new restrictions here. But it turned out it's the same restriction in both places. So my domain is all reals. X cannot equal to 0. Go the other way. G of f of x. Take this, put it in there. This one doesn't have any restrictions. So when I put that in, I'm going to get 1 over x plus 1. But I do have a new restriction now. What is my x? What number x cannot be, Caroline? Okay. So domain is all reals. X cannot equal to negative 1. So I do have that restriction, so I got to take into account for that. Okay. We're done with that. So let's go to section 5. We're back to all domains again. Caroline's favorite section here. I'll be calling on her to help us out because she knows. Oh, section 5. 3. Section 5.3. Alright. I thought the 2 was the hardest one, but 3. H of x is equal to square root of x minus 1. Okay, this is the last time, people. Come on. Domain restrictions occur when you have fractions because you can't have in the you can't have what in the bottom? 0. Domain restrictions occur when you take even roots because you can't have what inside the radical? Negative. Domain restrictions occur when you have logarithmic functions because you cannot take logarithm of negative numbers. You got to make sure everything inside the log is positive. Other than that, we're all good to go, at least for right now. Okay? So this is an even root, so that means my x has to be greater than, x minus 1 has to be greater than 0. Or it can equal to 0. So x is greater than or equal to 1. So domain is all reals. X is greater than or equal to 1. If you want this in interval notation, it'll be brackets on 1 and positive infinity in parentheses. This is the interval notation. Usually College Board likes interval notation. They'll ask you on the AP test, write answers in interval notation. Okay. We're not going to worry about the range. Range is what we cook on for right now. Okay. Alright. How about section 4? Yes. 6. 5. The first 6. Okay. What's that? The second 6? There's only A and B in second 6. You want the first 6? Fine. 5. F of x is equal to x squared. I'm hearing voices again. Okay. I'm not even going to insult your intelligence by doing that. Fine, I will insult your intelligence by doing this. This just means x plus 2 squared minus x plus 2 plus 1. For those of you that are algebraically challenged, if you leave it there, I will give you full credit. But if you think you want to impress me with your lack of algebra skills and continue on and make a mistake, we'll start taking points off. So the moral of the story is quit while you're ahead. Okay, C. We know who we're talking about. Don't you go around doing that, okay? Alright, f of x plus delta x minus f of x all that over delta x. Oh, this is 5. Okay, fine. It's the same thing. You'll see next week. H and H. First, we're going to find that. That means go to this function, put in x plus h. So x plus h squared minus x plus h plus 1. Any questions? Minus. Put in f of x, which is x squared. You better put parentheses. If you don't, I'm going to take a point off, or 2, over h. Please stop there, because if you go any further, next week we will have to go further. But this week, stop right there. 6. F of x is equal to 1 over x. A, they want you to find f of 0. That is no solution. B, they want you to find f of x plus delta x, which means 1 over x plus delta x. That's all it means. C, they want you to find f of x plus delta x minus f of x, all that over delta x. So we already found this in the last part, which is 1 over x plus delta x minus f of x. F of x is 1 over x, all that over delta x. Oh, don't even try to attempt to do this one. Leave it right there. Okay, 6, the second 6. F of x is equal to 1 over square root of x minus 1. Okay, they want you to find f of x. What? Just b. F of 2, all that over x minus 2. Okay, f of x is 1 over square root of x minus 1 minus f of 2 means you're going to put in what in place of the x? 2. When you do that, take square root of that, it's going to turn into 1. So that's 1. And in the bottom, you're going to put in 2. 2 minus 2. Done. Alright, B. F of x minus f of 1, all that over x minus 1. Okay, f of x means 1 over square root of x minus 1 minus 1 over square root of 1 minus 1, all that over 1 x minus 1. No, this one should be x, I'm sorry. Yeah. Change that to x. Sorry. Bottom doesn't change. Oh, there's a reason we're doing this. Yes, we're getting there. But that's good. Yeah. This is part of definition of a derivative. Yeah. Just leave, that's all we're going to do. We're going to leave it there. Alright, how about section 3? We're good? Parallel lines, perpendicular lines. How about symmetry, Mr.? You keep asking me questions on Facebook about symmetry. There you go. Good. Glad you came. Which one do you want me to do? This number 5. Okay, that's 2 questions. 5 and 6. Alright, 5. We're checking for symmetry. That's 3. Okay. Symmetry. Okay, here we go. We already talked about that just a second ago. When a graph is symmetric to the y-axis, that's even. When the graph is symmetric to the origin, that is odd. How do we check? We replace x with negative x. And that's what we're going to check. And then we're going to check the symmetry for the x-axis in a second. Okay, so number 3, we have x squared y minus x squared plus 4y is equal to 0. Okay, we're going to replace x with negative x and simplify. When I do that, we can do that in our head. When I do that, that turns into x squared y. This turns into negative x squared 4y. What happened? It turned out to be same. So that means it's even, it's symmetric to the y-axis. Okay, we're checking for x-axis. A graph like this is symmetric to the x-axis. That means this time we're going to replace y with a negative y. And if you get the same thing, then it's symmetric to the x-axis. So here we go. Take a look at this, and let's replace y with the negative y. This now turns into x squared times negative y minus x squared minus 4 or plus 4y is equal to 0. Clean it up. You're going to get negative x squared y, okay, minus x squared plus 4y. You mean at the end? Yeah. Okay. We're going to multiply everything by negative 1. Okay, and that will give me, okay, x squared y plus x squared plus 4y is equal to 0. Is that same as that? No. So it's not symmetric to the x-axis. So it's only symmetric to the y-axis. Not the origin, because when we checked x with the negative x, it didn't give us opposite value, so it's not symmetric to the origin. Okay, number 5. Y squared is equal to x squared minus 4x. We're going to replace x with the negative x. Okay, when you do that, you're going to get y squared is equal to x squared plus 4x. Is this same as that? Is it opposite of that? No. If it was opposite, means negative of x squared minus 4x. That's what means opposite. What is that? Is it x cubed? Okay. Fine, x cubed. Alright, then that will give me negative x cubed, right? Okay. So, is that opposite of that then? Yeah. So this is opposite of it, so it's symmetric to what? Origin. Okay. Now, how about the y-axis, or the x-axis? Replace y with the negative y. So give me y squared is equal to x to the third minus 4x. Is it symmetric to the x-axis? Yes. X-axis. Because it gave me the same thing. Okay. 6. Y is equal to x over x squared plus 1. Alright. Let's replace x with a negative x. I'm going to get y is equal to negative x over x squared plus 1. Is that same as this one? No. Is it opposite of the original one? Yes, so it's origin. Alright, let's replace y with the negative y. Is it the same as this one? Nope. So it's not symmetric to the x-axis. So it's only symmetric. What's that? No, when we say it's symmetric to the y-axis, no. It's so only origin. All right. I think we're done with this part. I'm not going to. Do you have any questions on the first part? Any problems on the first part? What's that? Lebna has a question. Lebna isn't even here. Number 12? Number 1 through 12 on section 1. Number 11. Okay, x to the 4th minus x is less than or equal to 0. The only way you can solve this is by number line analysis. Here it is. Factor out an x. I get x to the 3rd minus 1 is less than or equal to 0. You better factor that some more. That's difference of 2 cubes. I have an x minus 1 times x squared plus x plus 1 less than or equal to 0. I get no solutions from there because that's prime. I cannot solve that. But I get x is equal to 0 and x is equal to 1. Those are my critical numbers, so I'm going to use that as my number line analysis. Okay, 0, partition. 1, partition. Pick a number. Any number to the left of 0. Okay, this would be negative, this would be negative, and this would be negative. This is always positive. Okay, so it will be positive, then be negative, and be negative. Well, where is it negative? It's negative in that region. Okay, that means interval notation, it's going to be 0 to 1. That's my solution. Okay.